So today we're going to cover something that should sound familiar. Okay. We've never done it before, but it should sound very familiar. It's called the second derivative test. We've done the first derivative test last week. This is the second derivative test. Okay. So this is a test not on the first derivative, not on the original, not on the first derivative, but the second derivative. Because the second derivative tells us information about the original function. Okay. So what the second derivative tells us is it described, so the first derivative, so let's start with the first derivative. What does the first derivative tell us? What does the first derivative tell us? First derivative tells us one of three things. What does the first derivative tell us? I'll give you a hint. I'm not going to tell you. Yeah, Donnie? Or sorry, Srishti? Mm-hmm. Tells us one thing, increasing, right? That tells us one thing. Positive derivative means increasing. What's the other two? Go ahead. Go ahead. Uh-huh. There you go. It tells us three things, right? It tells us if the derivative is increasing, if the derivative is positive, the function is increasing. Derivative is negative, it's decreasing. The derivative is zero, it's called a critical value. It means it's not doing either. It's not increasing or decreasing, right? That's what the first derivative test tells us. So the second derivative test tells us another piece of information. That piece of information is called concavity. Okay? So concavity comes in two flavors, two types. Concave up, concave down. Concave up, concave down. Okay? Something that's considered concave up holds water, right? It's not a really good term, but it's kind of a way to memorize it. If it's concave up, it can hold water, right? But that's not always the case because you'll have things like this that are concave up, and that technically can't hold water, but it is concave up. So anything that kind of looks like holds water is concave up. Opposite is concave down. Anything that looks like this. So if I said draw a picture of something that looks concave up, it would have a curvature that would cup. It's kind of like a cup, but with arrows up. Okay? Or concave down. Okay? Okay? So those are the two things that it will tell us. That first second derivative test tells us. Okay? Concave up, concave down. What do you notice about something that's concave up in terms of what we've already talked about? What do you notice about this guy here? Something that's concave up. What do you notice about it that using vocabulary we've already used last week and the week before? It's doing both, right? It's increasing and decreasing. Good. What else? What else? Mhm. It's decreasing here. This dot right here, I think, would have a zero derivative. And then after that, it's increasing. Good. What else? One other thing. If something is concave up, what is it always going to produce? Mhm. It can be a U shape or it can be half a U, right? If I draw something like this, I can draw a picture. Let me draw a better picture. I can draw a better picture. I can draw a picture like that. That's kind of half a U, right? But that's concave up. That's considered concave up from dot to dot. But what is it always going to produce? Or what is it going to produce? What is this guy going to produce that this guy won't? What will it produce? What does this guy have that this guy doesn't? or vice versa. There you go, maximum minimum, right? Something that's concave up isn't going to have a maximum. If it's concave up, it's going to produce at least a minimum. It's going to produce, it's never going to produce a maximum, I should say. Never going to produce a maximum. If you want to produce a maximum, you have to be concave down. You have to. Okay? So those are the two things, those are the things that are related to what we've been doing. So just like I gave you a table before, this is another important table. Okay? It's highlighted on mine because it's super important, just like the last one for first derivative tests. Okay? If the second derivative is positive, what does that tell you? Well, that tells me it's going to be concave up. It's going to be concave up. So if the second derivative is positive, it's going to be concave up. If the second derivative is negative, it's going to be concave down. If the second derivative is 0, it's not going to be either. It's not going to be either. It's not going to be concave up or concave down. It's going to be, it's going to look like one of these points down here. Okay? So if it's 0, what does it look like? It's called an inflection point. It's not called a critical value. It is technically a critical value, but it's got a different name. It's called an inflection point. So when it's equal to 0, it has no concavity, and it's called an inflection point. One of the biggest questions they're going to ask you is, where are the inflection points? That's what that is just the critical values of the second derivative. The critical values of the second derivative. What does it look like? It looks like that. Those two dots right here are inflection points, right? Before the dot, it's concave down. After the dot, it turned to concave up. At the dot, it's not concave up or concave down. It's kind of stuck in between. Same thing here. Before the dot, it's concave up. After the dot, it's concave down. Okay? So that's what inflection points are. They're critical values, but for the second derivative. The second derivative. Okay? Let's see. All right. So we're talking about concavity. Okay? So this guy here, this part here is considered concave up. But that I wouldn't describe as holding water, right? Because if you put water in, it's just going to dribble down. But this is considered concave up, right? It's got the minimum on the bottom, okay? This is concave down. Okay, so that's what it tells us. Where is it concave up? Where is it concave down? Okay, here's a couple more pictures. Here's a couple more pictures that you can see. Concave up before the dot. After the dot, concave down, right? It's like, where is your cup? Is your cup upside down or right side up? By cup, I don't mean an actual cup. I mean, if you cup your hands, that kind of thing, right? Concave down, concave up. Okay, this is kind of the picture that we saw. This is another picture. This is concave up. This is concave down. Okay, the dots are inflection points. It's where it changes from one to the other. Okay, so that's what we're doing today. We're focusing on concavity. All right, that's what the second derivative test tells us. Okay, example number 1. We determine intervals where it's concave up, where it's concave down, and any inflection points. Okay, so what do we do? Don't look at me. What do we do? That's the first thing we're going to have to do. So do that. Find the second derivative. You got to find the first derivative first, So do that, and then find the second derivative. Then look up here and see if we have the same derivatives. Okay, so second derivative, 6x minus 6. Found the first derivative, found the second derivative. Okay, we don't really care about the first derivative right now. That's not my concern. It's important, but not for this problem. Okay, we would need to focus on the second derivative. Okay, so let's go back up here to find an inflection point. That's the critical value. So how did we find critical values for the first derivative test? What did we do? And that's what we're going to do with the second derivative. Set it equal to 0. It's the same process, just with the different derivative. Okay, so 0 equals 6x minus 6. Add 6 to both sides. X equals 1. This is a critical value, but it's got a special name because it's the second derivative. It's called an inflection point. Inflection point. Right? At 1, it changes from either concave up or concave down or vice versa. So what we just found is this guy here. I don't know what it looks like, and I don't know what it changes from, but it changes from one to the other. So before 1, it was either concave up or concave down. After 1, it was the opposite. Okay? So the question is, we need to figure out what was happening before 1. So this should look familiar. We draw a number line. We only have one critical value. So I need to figure out if the second derivative was positive or negative before 1. So what do I need to do to figure that out? This part you've done before, not with the second derivative, but you've done it before.
For the second derivative before and after 1.
There you go. And see if they're positive or negative. That's it. So any value before 1 is okay, but since 0 is probably the easiest number to plug in, I'm just going to plug in 0, especially because I can't use a calculator on this. So you get negative 6. Negative 6 is a negative number, so that means any value I plug in before 1 to the second derivative will always give me a negative number. Now I'm going to pick a number after 1. 2, 3, 4, any number you want. It's not limited. I would pick a number that's easy to use, but you're not limited to small numbers only. Okay, that's positive 6. Okay, so what we know is before 1, it's concave down. Okay, so let me write that down. So before 1, concave down. After 1, concave up. Okay, so let's answer the question. The question says, identify where each of these is happening. So the first one is concave up. Concave up. Well, let's see. It says determine intervals. Yep, so we have to. Yep, so start at 1, and we go to positive infinity for concave up. Concave down next. That's from negative infinity to positive 1. And then inflection points. Do we know the point?
We only know half the point.
We know x is 1, right? So if we wanted the other point, how would we find it? If I wanted to know, plug into the original, right? Plug into the original. Now for today, I'm not going to do that, but if you need to, you can do that. Okay, so I'll just say inflection point at x equals 1. But sometimes on a test, they will actually want the point. We'll just plug it back into the original and you'll get 1. It'll be 1 comma, what is it? 1? I think 1 comma 1. 1 cubed is 1 minus, yeah. Yeah, that's what I just did. Okay. All right. Okay, so I want you to do number 2 now. Do number 2. Same question, different function. Okay, so second derivative. First derivative, I got negative 8x over x squared plus 3 quantity squared. And then I did the second derivative. I stopped because of my next step. I did the quotient rule again. And then I stopped. Okay, quotient rule is something you should be really good at by now because we've done it a while. We've had a test on it. So this should be something that little mistakes will happen here and there, but it shouldn't be something where you're like, you get stuck, right? It should be something that you're like, oh, okay, I know what to do, right? Little mistakes will happen. I'm not talking about little mistakes. I make little mistakes all the time, but I'm talking about big mistakes. Yes, you could. Yep. Yeah, I was thinking about that. Yeah, you could do that. Yeah, absolutely. You could see that these are two terms, right? This guy's got one of these guys. This guy's got one of them, and then a GCF like that. Yeah, absolutely, you could do that. I didn't do that, but you could. Yes, that probably is better because then it gets rid of this squared part here. So I stopped here because that's all I need to do. This is my second derivative. Okay, is it simplified? No. If on a test they said find the second derivative, this answer wouldn't be A, B, C, D, E. It wouldn't be there because it's not simplified. But we're done with those tests. That test was last chapter. This test is okay. How do you use it? And that's what I'm more concerned about. How do I use it? Okay, so this is my second derivative. Not simplified, but it is my second derivative. Okay. What do I need to do with my second derivative? How do I use it? What am I doing with my second derivative? Why did I find second derivative today? Okay, I'm going to need to find the inflection point. How do I do that? Okay, so when is it equal to 0? When the numerator is 0, right? So I just need to set the numerator equal to 0. That's what I'm going to do next. Okay. See, let me give myself some more room here. Okay, so I'm going to rewrite the numerator. Minus 32x to the 4th plus 96x squared equals 0. Okay. So I got to simplify this first. Now I have to simplify. I can't do distributive property. I cannot do distributive property because I have to take care of exponents first. E comes before M in PEMDAS. M is multiplication. E is exponents. So you can't distribute yet. So before I can distribute, though, I need to multiply. So x squared plus 3 times x squared plus 3. First is x to the 4th. Outer, inner, those will both give me plus 3x squared plus 3x squared last gives me a positive 9. So I get x to the fourth plus 6x squared plus 9. Move it back in. Okay, now I can do distributive property since I don't have power anymore. Minus 72 minus 32 x to the fourth plus 96 x squared equals 0. Okay, combine like terms. Negative 28 x to the fourth positive 48 x squared minus 72 equals 0. It's a trinomial. So GCF, I believe -4, if not higher. Let's see. So 7x to the fourth minus 12x squared plus 16? No. Yes.
So wait, we had it, so as it is -8x to the 4 and -32x to the 4.
Oh, so it should be get bigger, right? Yeah. Sorry, I thought one of them was positive. So that is -40. I think 12 goes into all of them. Nope, 12 does not go into all of them. Okay. I guess 4 again goes into all of them.
What about -8?
Will -8 go into all of them? Let's use that then. Yeah, if you see something, don't sit there quietly. Tell me. Stop me before I go too far. Okay. So we got -8, 5x to the fourth minus 6x squared plus 9 equals 0. Okay. So let's see. This is just a math 3 problem here that we got to figure out. Let's see, 9, 5. What multiplies to be 45 and adds to be -6? What? There's got to be something. Let's see, 45, -6. We got 9 and 5, 15 and 3. Unless I did something, unless I made a error somewhere around here. I don't have the right numbers. Let's see. -48, -72. -40, +48. Negative 72, that's right. I must have made a mistake somewhere around the way. So I'm going to go back. I'm going to go back here. I'm going to go back to this step right here. I'm going to go back to this step right here. I made a mistake somewhere, but I can't find it. So in lieu of time, what I'm going to do here is I'm going to rewrite this, but I'm not going to use these. I'm going to do what Srishti was talking about earlier, which I should have done at the beginning. Do it a different way. So we have negative 8x squared plus 3 squared, and then plus 32x to the squared. Okay. That's the second derivative. What I should have done at the beginning was set the top equal to 0 like that. The reason is, like Srishti said earlier, they have a GCF. What's their GCF? Here had a GCF of, what was it, negative 8? This one has a better GCF, bigger GCF. What is this GCF here? Yeah, they both have x squared plus 3. So I can divide this guy by x squared plus 3. I can divide this guy by x squared plus 3. Yeah, you can also do that. Yeah, you can also divide by a negative 8 because they also can be divided by 8 as well. Good. As big as you can. Take out the biggest chunk as you can. So we're going to have negative 8 x squared plus 3. So that just leaves 1 power of x squared plus 3. And then over here, you're just going to have a negative 4. Oh, yeah. Thank you. That's a lot easier to work with. Why is this a lot easier to work with than the one we were doing earlier? I'm doing the same thing. I'm just using different methods. One method is using a GCF. One method is using quadratic methods. Why is this one a lot easier to use? Huh? Yeah, this times this times this equals 0. So what do we know? One of them has to equal 0. We don't, negative 8 can't be 0 because negative 8's a number. So I'm not worried about negative 8. But one of these guys has to be a 0. So I have to set them equal to 0. And I think I know why I wasn't getting an answer earlier. Why wasn't I getting an answer earlier when I was doing that, when I was doing the other one? Can anyone tell me? Why wasn't I getting an answer when I was trying to solve it the other way? I wasn't doing it wrong, but why was I not able to get an answer? More of a math 3 question then. It's not even a calculus question. Why wasn't I able to get an answer? Oh, maybe I'll put it on the next test then. All right, no one wants to tell me? I'll put it on the next test. Tell me to speak now or speak later. I don't think you want to speak later because it'll be on the test. Yeah. No, that was right. All of this was right. There's nothing wrong here. Everything here is correct. But I'm asking, why wasn't I able to get an answer here? I don't mean to make you feel bad, but my math 3 students can tell me this. I don't mean to make you guys feel bad, but you should be able to tell me this. Why wasn't I able to get an answer here based on here? Well, finish the problem. Finish the problem then. Tell me what you get. Finish the problem. What do you get? Mm-hmm. Mm-hmm. There's an imaginary number. One of your answers is going to be imaginary. What squared is going to be -3? Nothing. There's no real number that if I take the square root, it's going to give me -3. That's imaginary, right? This does not work with imaginary. This does not work with imaginary. You have to use quadratic formula to get your imaginary answers. That's exactly what we're talking about in Math 3 right now. Okay, and you talked about it in Math 3 when you took Math 3 last year. Okay, whether it's Math 3 or Math 3 trig honors, that's one of the things we talk about. Is when do we get real answers? When do we get imaginary answers? Well, we can't use this method if we get imaginary answers, so that's why it didn't work. So only way that, and there again, there was nothing wrong here. Everything here is correct. If I wanted to solve using this method, I would have had to use quadratic formula here. Plug this into quadratic formula. A, B, C, right? This is the stuff that's going to hurt you on tests. And there's not one part of calculus in here. This is all Math 3 stuff, right? Which is why the summer assignment is so important, right? The summer assignment is probably the most important test, quiz, whatever you want to call it, of the whole year. Because if you can't do the stuff on the summer assignment, calculus is going to be tough. And that's the thing. There's not a lick of calculus on the summer assignment quiz. Okay? So one answer is not going to give me, so it's going to get imaginary, so I'm not worried about that one. This guy is going to give me an answer, though. So let's go. -3x squared plus 3 equals 0. Subtract 3 from both sides. Divide by 3, divide by 3. 1. X squared equals 1. That I can take the square root of, because that's a positive number. So I get +1 and -1 as answers. So I get 2 answers. Anytime I take the square root of something, you always get 2 answers. Those are my inflection points. Inflection points. Okay. So let's go back. We got a -1, we got a +1. Oops. I didn't check the bottom. I never set the bottom equal to 0. When I stopped here, I just set the top equal to 0. Is it important to set the bottom equal to 0? It's kind of a trick question. Is it important to set the bottom? I set this part equal to 0. That's where I got +1 and -1. But how about this one? Is it important to put this guy, set this guy equal to 0? Kind of a trick question. Not really, but kind of a trick question. Is it important to set this guy equal to 0? The answer is yes. It's very important. But why didn't I do it? Huh?
When the denominator equals 0, you're going to get an undefined answer.
Which is extremely important. But why didn't I do it? Did I do it wrong? Did I do the problem wrong? This is something we talked about last week, guys. Yeah. Say a little louder. I couldn't hear. No, I need to check this. I should have set this equal to 0. I should have done the exact same thing I did here with that. So I should have done x squared plus 3 to the 4th equals 0 as well. But why did I not need to worry about it?
Since the whole second derivative is a fraction, likely.
It's a fraction, okay, but that
Yeah, but when you set the denominator equal to 0 in a fraction, you are likely going to make the whole thing undefined.
that's true. But why did I need to set it equal to 0?
Maybe it's imaginary.
Because also there's no real number. There's no real number here that's gonna make that 0. It's gonna be imaginary again, right? Not always though. Not always. So you got to check that. I skipped it, but I came back. The reason I'm addressing it now is because that's a step I didn't do, but you need to do it. Okay? Unless you know it's already going to be imaginary. This guy's going to be imaginary because there's no number I can plug in here that would equal 0. If I plug in 0, it's going to be 3 to the 4th. That's 81. If I plug in -3, that's going to make +9 plus 9 to the 4th power. It's never going to be 0. This is never going to be able to be 0. Never. Okay? That's why. So I wanted to come back to that and say, but you didn't do that. Yes, I did. But I didn't need to because I knew we talked about this last week. It can never be 0. Okay? Okay, so now second derivative. Second derivative. Plug in numbers. Plug in numbers. Tell me if it's positive, negative, or 0. Or it won't be 0. Positive or negative. Okay? Plug in 0 everywhere I see an x. So I get -8 times 3 squared plus 3 over 3 to the 4th. I don't care if it's what number it is. I don't care what number it is. I just want to know what sign it's going to be. So on the top, on the bottom, I see I get a positive number. I'm going to get a positive number. Okay. On top, I see that this guy right here is going to be something big. Negative 72, I think it is. Plus 3. That's going to be a negative number. So you're going to have a negative divided by a positive, which equals a negative number. If you don't believe me, just keep doing the math. -72 plus 3 divided by 81. Okay. Now I got to plug in a number bigger than 1. 2. Same thing. I'm going to plug it in. Anywhere I see an X, I'm going to plug it in. Again, I don't care what number I get. I just want to know if it's going to be a positive or negative number. That's all I care about. Okay. So we get -8, 4 squared. 2 squared is 4 plus 7 plus 3 is 7 squared plus 32 times 4. 32 times 4 times 7 over 7 to the 4th. Okay. Well, bottom's going to be positive because as we said, bottom's always going to be positive. The top, -8 times 49. Is that going to be bigger than 34 times 7 times 20, 32 times 28, really? Which is going to be bigger? Yeah, this guy is going to be smaller, actually, than this guy here. So you're going to have a pot. If you don't believe me, like I said, actually do the math. You just can't use calculator. Okay? So that means we're going to get a positive answer. So again, do not assume that less than -1 is positive. Oh, it fits the pattern. We saw one on Friday, Thursday. We saw one on Thursday where it wasn't positive. It was actually stay negative. So don't assume. You actually have to check numbers that are less than -1. Okay, so we know the bottom's going to be positive. Bottom's just always going to be positive. We said that. So I don't even need to check. But the top could be positive, could be negative. So let's see. -8, -2 squared is 4. So it's going to be -8 times 7 squared again. 32 times +4 times 7 over a positive number. So it's the same type of problem we had last time, right? So that we said it's going to be positive over positive. Okay. So now we got to answer the question. Concave up. Concave up before -1, after +1. Or after +1. Concave down. Between -1 and +1. And inflection points. At x equals 1, x equals -1. Okay. All right. So we're not going to finish the next one, but at least we'll be able to get it started. Okay, here's a little cheat sheet. When they say, because they're going to ask you for both, they're going to say, when is it increasing and concave up? When is it decreasing and concave down? When is it increasing and concave down? When is it increasing and concave up? They're going to ask you all of those things. So what does a picture look like? So like the first question they tell us on the one we're going to do in a second here, decreasing concave up. So what has to be true to be decreasing and concave up? What has to be true for decreasing and concave up? I'm seeing a lot of kind of stuff we should know. Maybe we'll have a quiz this week on this stuff. Short quiz on it. Because this is stuff you guys need to know. Test scores aren't going to go up if we're not practicing this. I told you guys, you got to practice this, practice this. This is not even anything, this is just memorization. Right there. I have them highlighted. If you didn't know, I have them highlighted right there.
Oh, when the second derivative is greater than 0.
Use your cheat sheet. Where is it? Find the box. Find the cell. There's 6 cells, or 9 cells. There's 9 cells. 1, 2, 3, 4, 5, 6, 7, 8, 9. Find the one we're talking about. Cell 3 right here. There we go. So what goes there? So how do we know? So it's got to be first derivative's got to be negative, right? And second derivative's got to be positive. That's what we're checking. Where is the first derivative negative? Where is the second derivative positive? Okay? So I want you to do right now is find the first derivative and find the second derivative. It's a combination of what we did last week with what we're doing today. Which one should I do first? Should I do increasing, decreasing, or concave up, concave down? Which one's probably easier to do?
Concave up.
That one's probably the easier one to do because it's linear. This is quadratic. So it doesn't matter which one you do. I need to know one of two things. Where is it increasing? Where is it decreasing? Where is it concave up? Where is it concave down? Those are the 4 things I need to know. Because once I do that, then I can say, okay, where is it? So you're going to need to do both. We're going to need to do both the first derivative test and the second derivative test for this guy. It's a combination. These questions, they love on tests because it has first derivative and second derivative built in. Okay? So that's what we're going to do. We only have 3 minutes, so we won't be able to finish it, but that's what we're going to do. First thing tomorrow, we're going to come in and we're going to finish this problem. Okay? Or if you want to be a little bit ahead, finish this problem before you get there tomorrow. That's up to you. Okay? But like I said, you're only going to get better the more you practice. The more you practice, the more you